Students, you are welcome to Uniclass Academy tutorial. This tutorial is is 102, that's optics, sound, and wave. Okay, optics, wave, and sound. We are on geometric methods, geometric optics rather, geometric optics. Okay, in previous lessons, there are certain things that have been taught. Okay, like when we have, this is concave lens, concave mirror, is a reflecting surface. The inside here is the reflecting surface. Okay, so the concave is concave, reflecting surface. Okay, and then for a convex, this convex, this is the back of the convex mirror. So this side is the reflecting surface. Okay, this is the reflecting surface. Now there are different kinds of image that may be formed depending on the reflecting surface or the mirror. This convex mirror. This convex mirror. So depending on the mirror we are considering, the image also may be different. Now for concave mirror, okay, if the object is that let's assume we have object, we have image. Okay, so if this is like a relation, so if the object is at F, the image is formed at infinity. Okay, now if the object is F means focal point, so if the object is at C, the image is formed at C. Okay, and then the image that will be formed here will be the same size as the object. Okay, and it will also be inverted. As you are listening the taking notes, okay, alright, so and then if the image is between F and D, where D is the vertex or pole, okay, the image will be formed, is going to be the image will be, the image will be virtual. You can get this in the previous slide, this particular one that is in the screen. So the image will be virtual, okay, and then will be reversed. Okay, the image will be reversed and then will be virtual. It's even going to be magnified. It will be magnified, it will be reversed. Okay, so if the image, so this one is like inside. If you read the slide, there is a place that talks about inside. Okay, so that's the inside aspect of this. That is inside, between the, look at this, when we have the concave mirror, this is F, this is B, and this is C. So inside here, this is talking about inside. So if the object is here, the image will be somewhere here, and then to the virtual. Okay? Now, we come to this. Yeah, so if the image is at F, if the object is at F, the image will be formed at infinity. If the object is at C, the image will be formed at C. If the object is at infinity, the image will be formed at F. Okay? Now, so if the object is at C, the image will be formed here. It's going to be inverted. Okay? Something like this. So this is the image. Okay? This is the image. So depending on, so you should know all these things, okay? And be able to memorize them. Now also, when we say object, we have image. C for concave lens, concave mirror. C for concave. If the object is between C and F, if the object is between C and F, okay, the image will still be away. It's going to be away. Alright, you can check the other properties of that image. If the image is behind C, but not at infinity now. If the image is behind C, it will still be away, okay? So like the instance where the image will be virtual is when it is between C and B, that's between C and between F and C and B rather. It will be virtual between F, that's in this case. Between F and B, the image will be virtual. Okay? So, and this is the image. Alright. So we're able to go through those things. Now, if you are not dealing with convex mirror, this is the reflecting surface, okay? Alright. So this is very for the position of the object. I think that is the way it is for convex mirror, okay? Irrespective of the object position, the image is going to be virtual, okay? The image will be virtual. So this object is image. And from here to here is the object distance, from here to here is the image distance, okay? Alright. So the image is usually virtual, okay? Now let's see, we want to take certain examples because this course deals with calculation. You are going to do calculation. There are concepts, and you have to learn the concept, and then so I do calculation. Okay, and you have to get lambda physics volume 2 and solve questions in it. Now we also look at this equation where U is object distance, image distance, okay, this image distance, and F is the focal length, okay, so take note of this, and then F is equal to R over 2, where R is the radius of curvature. Okay? Radius of curvature. Now, take note of this relationship. Alright? So, and then it holds for concave mirror, it holds for convex mirror. Alright? So take note of this point also. For a plane mirror, we know that U is equal to minus V, okay? Because if you have a plane mirror like this, and the object is here, this is the reflecting surface, okay? Okay? Now, if the object is here, distance U, the image will be formed somewhere here, okay? The image will be formed somewhere here, same height as the object, okay? And then the image will be here, having a length of V, but in this case minus V. Why it is minus V? Because it is formed behind the reflection surface, okay? So it's minus V. So for a plane mirror, V is equal to minus V, okay? And then take note, when magnification that's lateral magnification rather. Let me just start with that, although that was not what I intended to write initially. So not lateral magnification is equal to image height over object height. Lateral magnification is image height over object height. and then image distance over object distance. Okay, over object distance. Now there is going to be a minus here. Take note. Okay, so if this is h prime and this is h, okay, image distance is h prime. Now this is symbol to represent it. Like in this case, you may read another page and then use that. Okay, so if this is v and this is u, then that means h prime over h is equal to v over u minus. Okay, so take note of this equation. Really important. So lateral magnification. Now, when lateral magnification is negative, when it is negative, it means the image is inverted. It is inverted. What that means is that it does not have the same orientation as the object. Take note of that. The image does not have the same orientation as the object. That means if the object is erect, the image is inverted. It does not necessarily mean whether it is vertical or real. It may not necessarily mean. Okay, because you can have an object, just take for instance, when you have concave mirror and you have at point C, you have an object placed here at point C for instance, and the image of this object is formed here and it is inverted. Okay, the image is inverted. So in this case, magnification will be negative. Okay, magnification here will be negative, but then take note that the image here is real. The image is real. This image I is real. It's a real image. Okay? So, but it is inverted. It does not have the same orientation as the object. Okay? It is inverted. The object is erect. The image is inverted. Okay? Now let's take some questions. The concave. There are about 5 questions I will take here. A concave mirror has a radius. I'm able to write the question. Has a radius of curvature. R equals to 25 centimeters. An object of height 2 centimeters is placed 15 centimeters in front of the mirror. Okay, what is the image distance? And then what is the height of the image? Now take note of this. When you are reading physics, read by focusing on the words also, not just the sentences. Take note of the words that are used. Now here, a concave mirror. Take note. We are going to use a concave mirror. So has a radius of curvature 25 centimeters. Okay. Now, an object of height. Now this is object, right? An object of height. So that object has height of 2 centimeters. Okay. Now, that object is placed 15 centimeters in front of the mirror. Now that means the object has this height and the object distance is 15 centimeters from that in front of the mirror, and the mirror is the concave mirror. Okay. Now, so we have concave mirror, radius of curvature of 25 centimeters. The object has the height of 2 centimeters. Okay, the object is placed 15 centimeters in front of the mirror. Okay, now what is the image height? What is the image distance rather? That's V. So I want us to find V in that case. So we have R equals to 25 centimeters. And from here, F will be R over 2. That's 12.5 centimeters. Okay? Now that's F. Now, of course, for concave mirror, R is positive, F is also positive. Take note of that. Okay? Now, then object height, let's call it A. That's 2 centimeters. Okay? Now, the object distance is U, which is 15 centimeters. Okay? What is the image distance? We want to find V. What is V? Okay? What is V? Let's use this parameter first. So we have F equals to 12.5 centimeters. U is equal to 15 centimeters. H is equal to 2 centimeters. I want to find V. What is V? How do you find V? Okay, now using the formulas that we have, 1 over U plus 1 over V is equal to 1 over F. Okay, we know this. Okay, we don't know this, so we can, and then we know this, so we can use that formula. So 1 over V now is equal to 1 over F minus 1 over U. So 1 over V is equal to 1 over 12.5 minus 1 over 15. So from here, if you evaluate, V is equal to 75 centimeters. Okay, V is equal to 75. Please take note, they must have the same unit. Okay, they must have the same unit. If height, we are dealing with height of the image. The height of the image must have the same unit with the height of the object. Okay, but this one and this one must have the same unit. Okay. Now we have answered the image distance because the question says what is the image distance. So we've gotten that to be 75 centimeters. What is the height of the image? Now that's A times. What's the height of the image? Now to find the height of the image, we know that A prime is equal to over A is equal to minus V over U. Okay, so A prime is equal to minus, our V is 75, our U is 15. Now times 8 now, okay, times 8. So that now that's the cross multiply. That means A prime is equal to minus V over U times 8. Okay, 8 now is 6. So when you solve that, we get minus 10 centimeters. So that means A prime is equal to 10 centimeters. Now take note, this minus sign is as a result of saying that okay, the height, the image is having another orientation as compared to the object. If the object is erect, the image is inverted. But the distance itself is going to be positive. Okay, the distance is positive that we have got here. And this one is the height. So you can't say that height is negative. The height is positive. So that's why it is 10 centimeters. The height is positive, but the negative sign shows that the image is having an inverted orientation, that is inverted. The lateral magnification always includes a positive sign when the image orientation is the same to that of the object. Okay, so M is positive when U and V That's excuse me, let me just put it this way. When the object and image have same orientation. Okay, they have same orientation. Then n is negative if they have different orientation. Orientation there is like talking about if it is erect, if it is inverted, okay? If it is erect, if it is inverted. So that question has been answered. Another question now is, let's take note of this. Alright. So, this question is tarantula of height of 5 feet sits cautiously before a spherical mirror. Whose vocal length has absolute value absolute value 40 centimeters. Now the image of the tarantula produced by the mirror has the same orientation. As the tarantula. And as height is prime equals to 0.208. Now the question here is the image real or virtual? Is the image real or virtual? And is it on the same side? Is it on the same side of the mirror as the object, or that as the tarantula, or the opposite side? Now let's look at this question. Now the question says that a tarantula, there are two questions, but the second one will see the rating later. A tarantula of height 8, so that's the object height, okay, 8. Now sits cautiously before a spherical mirror. Now they didn't tell us whether the mirror is convex or concave, whether it's concave or convex. Now a spherical mirror whose vocal length has absolute value of 40 centimeters. Now here, this information did not tell us if it is convex or concave. If it is concave, it's going to have a positive vocal length. If it is convex, it will have a negative vocal length. So this one now, it just gives us the absolute value. So we don't know whether this value itself is positive or negative from this question. Okay? The image of the tarantula produced by, so this tarantula has image. Okay, that's the object in this case now. So the image of that object produced by the mirror has the same orientation. The image that is now formed has the same orientation as the tarantula. Okay, image has the same orientation as the object now. Okay, and has height of 8 prime. So the 8 prime now, 8 prime is equal to 0.208. And this 8 is the height of the tarantula. Okay, now that means the image height is 0.208. Okay, that's the relationship between them now. Now, so what is the image real or virtual? That we want to do. Is the image real or virtual? And is it on the same side of the mirror as tarantula or the opposite side? Now, so take note of that question carefully. Now, from this information given, object height is given as 8. Image height is 8 prime equals to 0.208. Now we know that they have the same orientation, okay? Same orientation. That means if the object is erect, the image is also erect. Now from the previous lesson, we know that for concave mirror usually produce inverted image. It could be here, maybe here, I don't know. But usually it is inverted image. It only produces an erect image which is virtual. That's if you have, for instance, if you have F here, you have B here. If the object is somewhere here, if the object is here, the image of that object will be here. Okay? Now, so we know this information, right? Now, if you look at this, you observe that this object is having a height of 8 and the image is having a height of 0.208. That means 8 prime is less than 8 because 0.208, if you have a value for 8 and you multiply 0.202 times that 8, you observe that 8 prime will be less than 8. That means image height is less than object height. So in this case, this cannot be the case because in this case, 8 prime is greater than 8. Image height is greater than, look at this. So that cannot be the case, okay? Now, so what we now want to do is the mirror convex or is it concave? That's what we want to do. So now let's look at the information given. Okay? So when we look at the information given, we want to see so that it has the same orientation. Okay? That's same orientation. So if it has the same orientation, this one and this one has the same orientation. Okay? Now, this and this does not have the same orientation. Okay? And then if you place the object at infinity, the image will be formed at F. So we don't really, okay, and the image that will be formed at F is very small, okay, very, very small. Alright. So we are still going to use the kind of the information that we know about concave mirror and convex mirror. That's what we want to do. Now, but if you know that for convex mirror, the image is usually erect. If you place the object here, the image is usually erect and diminished. So this applies here. 8 prime is less than 8. Because it says that, and look at it, it has the same orientation. So the image is having the same orientation as the object. And the image height is less than the object height. Okay? And that goes with this. Okay, so the question is the mirror convex or concave? The mirror is going to be concave. convex rather. So the mirror is convex mirror. That's the answer. Why? Object has same orientation as the image. That's one reason, right? Another reason is this. Although this may apply maybe for, I don't even think it will apply for concave mirror, but this reason goes with it. The object has the same orientation, okay, that it is both erect, alright, and then the image height is less than the object height, and that applies if the mirror is a convex mirror. Okay, so we proceed now, and then in fact it is, and the question also asks us, it says, is the image real or virtual? The image is virtual, okay? The image is virtual. And is it on the same side of the mirror? It's not on the same side of the mirror. Okay, if it is virtual, then it's not going to be on the same side of the mirror. Okay, it's going to be, so this will not apply, this one will not apply. What applies is this. Okay, this applies. This is the object, and this is the image. So you observe that if it is convex mirror, the image height h prime is less than 8 in this case, okay, and then the image is virtual, is on the opposite side of the reflecting surface, okay, so it's not on the same side as the object, okay, so you get this kind of information. So you should try to know the kind of image that will be formed if it is a concave mirror or if it is a convex mirror. So the answer to this question is that it is a convex mirror. Why? Object has the same orientation as the image. Okay, the image height is less than the object height. Okay, so and then the image is formed. Image that is formed is virtual. The image is also on the opposite side, okay, opposite side of the mirror. Okay, the B part of the question is that is the mirror concave? Is the mirror concave or convex? Is the mirror concave or convex? And what is the focal length? F sign included. What it's saying is that the focal length is given as f prime absolute value to be 40 centimeters. Okay, so it's saying that what is the sign of this focal length? Is it positive? Is it negative? Now, because we have shown you that the mirror is convex. Okay, the mirror is convex, and then, but what is the sign of the focal length? If it is convex, it's going to be negative. Okay. Now, but let's just look at this information. N is equal to h prime over 8, and we are given n to be we are given h prime to be 0.208, and this h is equal to 8. That means magnification is positive. Okay, the magnification is positive. Alright. So if magnification is positive, we also know that n is equal to minus v over u. Okay, so that means 0.20 is equal to minus v over u. That means v is equal to minus 0.20 u. So from here, you can say that u, we know u, object distance, we know v to be equal to minus 0.20 u. Now 1 over f is equal to 1 over u plus 1 over v. Okay, so 1 over f is equal to 1 over u plus 1 over minus 0.20 u. Okay, that's this. So from here now, so 1 over f is equal to factorize 1 over u, and factorize 1 over u, we have 1, okay, minus 5, okay. This is 1 over 1 minus 1 over 0.20. That's why it is 1 over 5, okay. So now let's proceed. We have 1 over f. 1 over f is equal to 1 over u, 1 minus 5, okay. So that's what we have there. And then we proceed. We have 1 over f is equal to minus 4 over u. And then since u is always positive, okay, u is positive, okay, and then that means definitely f must be a negative sign. So f is negative, and then therefore that absolute value that gives us 40 centimeters means that f is minus 40 centimeters. It is only when it is minus 40 that this thing will hold. Okay? So that answers the question. The question is the mirror concave or convex? The mirror is convex. What is the focal length f sign included? The focal length sign is negative, and that answers that question. Now we look at one more question. Okay. Okay, 2 more questions. Let's look at this now. A lamp is placed 10 centimeters in front of a concave mirror. A concave spherical mirror. In front of a concave spherical mirror that forms an image of the filament on a screen placed 3.0 centimeters from the mirror. What is the radius of curvature? What is the radius of curvature of the mirror? What is the radius of curvature of the mirror if the lamp filament is 5.00 millimeter, okay, and just 5.0 millimeter high. How tall is its image? How tall is its image? So how tall is its image? What is the lateral magnification? What is the lateral magnification? Now look at this question. It says a lamp is placed 10 centimeters in front of a concave spherical mirror. Now, this is that lamp object, okay? 10 centimeters in front, okay? That's U is 10, okay? Now, U is equal to 10 centimeters. Okay? Now, that lamp is placed 10 centimeters in front of the concave mirror. So we have the mirror is concave. And, okay, that forms an image of the filament on a screen placed 3 centimeters from the mirror. Now, listen, the object is placed 10 centimeters from the mirror, okay? Now, so U is 10. The image is formed on a screen. The image is formed on a screen, and that screen is 3 centimeters from the mirror. That means V is 3 centimeters. Okay? The image is formed on a screen, and the position of the screen is 3 centimeters from the mirror. So V is 3 centimeters. What is the radius of curvature? So let's do that first. 1 over U plus 1 over V is equal to 1 over F. So 1 over F now is equal to 1 over 10 centimeters plus 1 over 3. Now, but this, excuse me, this says, okay, sorry, I need to change something here. This is in meter. In the question that is given is in meter. So I'm going to change this now to meter. Okay? This is meter. Okay? Now, so take note. I'm going to change V is in meter. So I must change it to centimeter. So that is 300 centimeters. Take note. So that's 300 centimeters. So you must put the unit in the same, they must have the same unit. Okay, so I made a mistake by writing centimeter here. And the question was in meter. So I have to change it so so this is the 300. So 1 over F now is equal to you solve this, okay, and because you solve it, and then F will be equal to 9.68 centimeters, okay? 9.68 centimeters. So what's F? 9.68 centimeters, and R is equal to 2 times F, okay? So that's 2, R is equal to 2 times 9.68 centimeters. And that gives us R to be 19.4 centimeters, okay? It's going to be in centimeters because this one is also in centimeters, okay? So that's in centimeters. That's radius of curvature. And the question also says that if the mirror is 5.0 millimeter high, so if the filament is 5 millimeter high, so that this filament now is the lamp filament, that's the object. So H is 5.00 5.0 millimeter. Okay, that's the height. The output is the image. Output is the image. So we want to do that. This 5.0 millimeter. So what is image height? So just write this relationship. H prime over A is equal to minus B over U. Okay. Now we want to find this, right? So H prime is equal to minus B over U times H, and that will be minus 300 over 10 times H, which is, now if you look at this is in millimeter. So, and then the reason why I could use it like this is because this one and this one is going to give us the same unit. Okay, if this one is having the same unit as this, it is still correct, and this one and this one must have the same unit. Otherwise, I should change this to centimeter first and then apply it here. So that means the answer I will get must be in centimeter. That's if I change it. But since I didn't change it, the answer I will get must be in millimeter. Okay? So you can choose to use the one you like. You can change this to centimeters so that the four of them here will be in centimeters. That means the answer you will not get will be in centimeters. Okay? But if I use it directly like this, the answer I will get will be in millimeters. So take note. So the answer here is going to be minus 30. Excuse me, not minus 30. It's going to be minus 150 millimeters. Minus 150 millimeters. So that's H prime is equal to minus 150 millimeters. So now, we've gotten, so the question is how tall is its image? So the image is, image height is equal to 150 millimeters. Now, another part of the question says, what is the lateral magnification? What is the lateral magnification? The lateral magnification, M, is H prime over H. So that's 150 millimeter divided by 5.0 millimeters. Okay? So the answer here is going to be 30 millimeters. Okay? Now, if I use the other value, which is from here, if I decide to use minus sign, okay? If I decide to use minus sign, or I use image distance and object distance, what we're going to get is that we say M is equal to minus B over U. That's minus 300 over 10. And that is minus 30. Okay? That's M. In fact, there is not supposed to be millimeter here. Magnification does not have units. So minus 30. Now, the difference there is just that in this case, I have put absolute value. So that's like saying I'm just using the absolute value. So I could have used minus sign there and I have just minus 30. So that negative magnification means that the image is having an opposite orientation. Okay? But the absolute value is just static. So the sign, the importance of the sign there is that it's going to tell you if the image is inverted or if it is erect. If it is negative, it means it has a negative orientation, an opposite orientation. That means if the object is erect, the image is going to be inverted. Okay? The image is inverted. So that's what the minus sign is there. Okay? The minus sign, that's what it implies. So let's take one more question. One more question. Rays from sun converge at a point 15 centimeters in front of a concave mirror. In front of a concave mirror. Okay? It says, here should an object, be placed so that its size, or so that the size of its image is equal to the size of the object. Now, listen to this question. Rays from from sun converge at a point 15 centimeters in front of a concave mirror. Now, take note, rays from sun very far converge at a point. So where the rays converge, that's where the image will be formed. Okay, so converge at a point, and that point is where the object is formed, so where the image is formed, right? Okay, so rays from sun at a very far distance converge at a point. That point where it converges is where the image will be formed. Converge at a point 15 centimeters in front of a concave mirror. So this 15 centimeters is the image distance, because it's 15 centimeters in front of the concave mirror. Okay, now that means B is equal to 15 centimeters. Okay, and since it's in front, it's going to be positive. That's why it is positive here. Okay, so ray from sun now converge at a point. That point, if ray from sun very far distance converge at a point, okay, from what was learned before, image if the object is from a very far distance, okay, it's going to converge at the focal point. So that means F is equal to 15 centimeters in this case, because the image is formed at the focal point. So that means in this case F is 15 also. Okay, so it's good to learn concepts, so that when you want to solve calculations aspect, you may apply the concept. Where should an object be placed? So what should be the distance of the object, so that the size of its image, that the image of that object is equal to the size of the object. So what should be, so that the size, it's talking about the size now, the size, that is A prime, should be equal to A. What should be the size, what should be the object distance? What should be an object, talking about distance, where should an object be placed, so that the size of its image will be equal to the size of its object. So looking at this information, so we want to find what is used. What is used? We want to find what is used. So we know that A prime over A is equal to minus B over U. Okay? Now, but we don't know U, alright? We don't know any of this, but we just know that they are equal to each other. That's what we know. Okay? We know that they are equal to each other. Then we know that U, 1 over U over 1 over B is equal to 1 over F. We know F, we know U. We know V rather. So we can easily find U. 1 over F minus 1 over V. So 1 over U is equal to 1 over 15 minus 1 over 15. Okay, no, this is not the approach to be used, okay? That's not the approach. Okay, so we know that U is going to be, since I say that where to be, let me explain it this way. I think the explanation I was giving earlier was wrong. Rays from sun, okay, since the rays are coming from a very far distance, in that case, U is infinity, okay? U is infinity at a very far distance, and then the image is formed at F, okay? The image is formed at F, okay? So, and then F is going to be 15, in this case 15 centimeters. In that case, F and G are the same, okay? Since it's concave mirror, so let me just look at this. When you have this, if you have C, you have F, you have G. If object is the ray is coming from infinity, if you convert here, okay, if you convert as f, so in this case, image distance is equal to z, okay, and it's both positive, alright. So, but object distance is infinity. So that is from that information, okay. Now, they now have to where should an object be placed. We are not talking about object here now. We are just talking about where should an object be placed so that the size of the image will be equal to the size of the object. That's what they are asking now. So now let's look at, okay, where should an object be placed? So we have gotten information about the focal length of this mirror, that the focal length is 15 centimeters. So where should an object be placed? So we just say 1 over u plus 1 over v is equal to 1 over f. So 1 over u now for an object is but we are not going to use formula. What they just want us to do is that where should an object be placed so that, look at this, where should an object be placed so that the size of the object will be equal to the size of the image. The only condition where that will happen is when the object is placed at C. That's it. When the object is placed at C, you observe that, so we don't even need calculation there. We just have F here, we have C here. Where should an object be placed so that the image size, H prime over, will be equal to H. That can only happen if the object is placed at C, and then the object height H will be equal to the image height H prime. This can only happen if the object is placed at C. So, where should an object be placed? So, the question they are asking us is that what is U? So that H prime will be equal to H for that particular mirror. Okay, for this particular mirror, what should it be? So that means that they're asking us to find this distance, and that distance is radius of curvature, and radius of curvature is 2s. So that is 2 times 30, and that gives us 2 times 15 rather. 2 times 15, and that gives us 30 centimeters. That's the question. So the question again is that we have rays coming from sun, that U is infinity, okay, converge at a point, and that point must be the focal point, okay. If it is coming from infinity, then it will converge at the focal point, okay. So that means the focal point is 15. You get that? Okay. That means the focal length rather. The focal length is 15. Alright. And it's in front of a concave mirror. So from that information, it now says that where should an object, not the object that is coming, not the one coming from here, right? Not the ray coming from here. Just talking about an object. So where should an object be placed so that the size of its image is equal to the size of the object? So that means here, for a concave mirror, where should an object be placed so that that can happen? It can only happen if the object is placed at C, which is the center of curvature. If it stays at the center of curvature, image height will be equal to object height. And the center of curvature is C. Okay? But what should be the distance from the mirror? The distance will now be radius of curvature. And radius of curvature is related to focal length by 2 times f. So from there you can get U equals to 30 centimeters as the distance of the object. So with this, we bring this to close. Okay. So this is Uni Class Academy. If you have questions, you may ask a question. Okay. and you send me WhatsApp message. Okay? Now, endeavor to solve questions in University Physics, LAMLAT, Volume 2. First year University Physics, LAMLAT, Volume 2. Questions that relate to this topic and practice there. Thank you for watching. Bye for now.